Hello guys, in today's tutorial we will look at half-wave rectification in Proteus. Please remember to subscribe to our channel below. Let's get started. So, as an electrical engineer, I assume you know the component used for half-wave rectification. For half-wave rectification, we need a diode, a resistor, and an AC voltage source. So let's pick our components. Remember how we picked our component? Let's pick our diode. Double click. Pick our resistor. Let's pick our voltage source. Remember, we are looking for a sine wave AC voltage source. That's the three components we are going to use for half-wave rectification. We click on the OK button and we place our component let's rotate this. Then we connect accordingly. So now remember, when we are designing a circuit, we have to put our reference, which is ground. We pick our ground and place. Right now, this is our circuit. We double click our voltage source. We want to set the amplitude and the frequency of our voltage source. We double click on it. Our amplitude, we set it to 220 volts. Our frequency, we're using 50 Hertz. And then we click our OK. Let's set our resistor to 12K. 12K. Click enter. Alright, here is it. I guess you should know the output of a half-wave rectification circuit. As we know, the output of a half-wave rectification circuit is a positive half cycle. How do we check it in Proteus? We can use our oscilloscope. So you go to our visual instrument. This is our visual instrument, or you call it the visual terminal, and select our oscilloscope. Here is our oscilloscope. You click on it. Then you place it on the simulation window. Place it on the simulation window. And now when connecting the oscilloscope, we are trying to get our rectification cycle from R1. So we connect our channel A of our oscilloscope to our terminal of our R1. After connecting everything and you see that the parameters are all good to go, we now play the simulation. Now you can see our oscilloscope at this point. We have to set the bands and the voltage of the oscilloscope so as to see our cycle well. So we are dealing with channel A. Remember, we connected our oscilloscope at channel A. So we go to our channel A and adjust the parameters of the oscilloscope. Like this, so that we see our parameter properly. So you can see the output of the rectifier circuit, the half-wave rectification circuit. You can see from the oscilloscope is being shown the positive half cycle. Now if we want to compare it to the input, we stop our simulation, we go back to our schematic capture. Let's see how our output is, our wavefront of our output. We place it to our output parameter here. So now remember, we connected our output to channel B. So we play the simulation. Now we go to our channel B and set the parameters so as for us to see it properly. We set our parameters properly. I'm trying to arrange it so that you see the difference. Okay, let's move this a little bit up. Let's set this, let's move up so that we can see we're picking it up. So okay, now you can see our channel B is the blue line, our channel A is the yellow line. So you can see that our channel A, which is the output, is the half wave rectification, while our channel B is our input, which is the sinusoidal wavefront we have. You can see that the input has been rectified by this diode, giving us a half-wave rectification circuit. Another way to see our output without using oscilloscope is by using graph. Let's check this out. We stop our simulation, go back to our schematic capture. We want to use graph instead of using oscilloscope. So we take off this. First of all, we click on probe mode, click on it, select voltage probe and connect across, place it on the simulation window and connect across R1. To see the graph, we go to graph mode, click on graph and select analog, because we are connecting AC voltage, so we are dealing with analog signal. So we select analog, we come to the simulation window and draw a rectangle where our graph is going to occupy. So now this is our graph. After drawing the scale, and the graph like this will show up. Then click on our voltage probe, click on it and drag it into the graph. Now to simulate the graph, put your pointer on the graph, right click on the graph, then go to simulate graph, click on it. You can see it's being simulated. Our wavefront has been shown in the graph here. We have to set our time limit to see the graph very well. We right click on the graph and go to edit graph here. Click on edit graph. We have to set our start time. Our start time definitely is going to be from 0. Then we reduce our stop time to 60 milliseconds, which is 3 cycles. So we click OK. You Gonna ask you to resimulate, click yes. Now you can see 3 circles appearing showing the half-wave rectification. In our next tutorial, we will look at full wave rectification in Proteus. Thank you.